just hold on. Okay, welcome guys. This is my son driving his electric go-kart. We have a 48 volt setup with a Kelly controller, solenoid, amp shunt. So we're running two 24 volt motors in series. Got a band brake with a differential. Double chains for the two motors on either side of the differential. It's not very fast. It's fast enough for him, but I wouldn't mind it being faster. And it's set up as aerial atom-ish, basically. You got a loom for our wiring. You got a 48 volt to 12 volt converter, and we got a bit of a amp meter, so keeps track of the volts and the ampage that the car is using. There's plans, well, let's just say that there's plans. Alright boy, go! You like your go-kart? Alright. So as he gets older, there are probably modifications to make this thing faster. But this is what we got for right now. And he likes it. So, next thing I'm going to add is something to hold down the batteries because they are loose. And probably a battery box to keep everything closed up. But, all along, it's working pretty good for right now for what we have. So thanks guys. We will be adding safety lights and all, of course, so he can drive later if he wants to. So we'll be adding halogen headlights, brake lights, signal lights, of course a flag, because he is low to the ground. Oops, sorry guys. So the construction is base frame is box tubing steel, as you can see in the frame there, as far as the main frame, and the outer supports is EMT piping to get the shape there. Alright, so this is my son's electrical go-kart scratch build. So here we've got the Variac pedal, brake pedal over there. So you see that it's made with EMT piping, but it's not entirely EMT piping. For the structural portion of this thing, we use box tubing along the bottom, all the way back to keep the strength of the thing. The EMT is used for somewhat structural but more decorative purposes. It's easier to work with. Almost easy. It's still kind of a pain to weld. So we have our brake linkage here. So we're using the band brake setup. Our voltage regulator. We're using 48 volts. This regulates it down to 12 for feature lights and other accessories. So we have our switch. I don't know if you noticed this earlier, but there's an indicator back there for our controller. It'll blink in a certain sequence depending on the state of the controller. Arrow lights and stuff like that. It's an adjustable seat so my older son can ride it too. I can squeeze in there myself if I wanted to. The rest of the brake linkage. So I said we're using 48 volt setup. We have 4 7.5 hour batteries. I wish I had the budget to change them out to the A123 batteries, but we have what we have. Our Kelly controller, our solenoid, contact solenoid, and our shunt, so we get the amperage readout on the display up front. We're using 2 24 volt scooter motors, 500 watts, so probably half horsepower each, so we're running basically 1 horsepower. I hooked it up in parallel before. We got speed, but the amp draw was killing the controller, so we have to do it in series, which kills the speed but increase the amperage handling so it lasts a lot longer. Now the wiring's a mess, but we're planning on building some type of box back here so it'll cover all this up neatly. We'll have a bit more work to do on the brake, but it works for right now. You see, I have to use heavy steel to reinforce the braking, but it still needs work. So, and we'll probably change these motors out for a single big motor that'll give us a bit more speed out of it. But it is for my son, the youngest son, so it'll do for right now. That's pretty much it, guys. Thanks for watching.